It's Torres for Torres Tech, and I'm doing a quick demonstration here about how sometimes you can have leaks inside of your machines without knowing it. This is a gauge manifold with a refrigerant hose that we were recovering with before, and it has refrigerant. So we have low loss fittings here. We have low loss fittings on the end of our hose here, so there's refrigerant trapped inside of this hose. This is the pressure inside of the hose. See that? Look. So this is one of the new tools that we're using to try to find leaks sometimes when they're not presenting itself. So you can actually see here the pressure's going up, but I can detect a leak over here on my ultrasonic meter. So you can see this is giving me an indication that there's a leak here. And then if I play with the line, you can see that's a pretty substantial leak. So what happens a lot of times is you can have small holes inside of refrigerant lines, whether it be at your flares, whether it be at your braze points. Sometimes you have mechanical fittings like your press fittings and things like that. And what will happen is because the machine is constantly vibrating, it can shake and loosen up those lines to an extent that a small leak that is not presenting itself can become a bigger leak over time, and you can lose your refrigerant. The problem that you have when you're using a blend like R410A is that you don't have to lose a lot of the refrigerant for the blend to get messed up to a degree that it loses its efficiency or its effectiveness. So you see here again, if I'm just looking at my pressures, this is why I always like to use digital gauge manifolds, because with an analog control you're never going to see little pressure drops here. But when especially installing heat pumps with flares where you might not be brazing, you have to do everything possible to make sure that it's not going to leak, because that machine that is working perfectly fine on day one might not be working perfectly fine on day two.